Good morning, everyone. My name is Jiri Chaloupka. I'm technical marketing engineer. And today I will talk about the EVPN as an important complement to the BGP-based services. Yeah, because I think that we talk about the transport, and there is a lot of new stuff going on the services side. And it's actually very good to look at how we can put all this stuff together, and how basically we can even simplify the services layer in the service provider network. I really like this slide, mainly because I created this slide. But another important reason is that when you look at this one, there is no any platform. This is purely about the protocols. Yeah. When you look at how we built the service provider network some time ago, or basically how the service provider networks are running these days, and how you can create a really large service provider network. You see the protocol stack on the transport side, the blue part, IGP, LDP, RSVP, then BGPLU for the interdomain LSP, and then on the services, the orange part, LDP for typical L2 VPN services, point-to-point, multi-point, and the BGP for the L3 VPN services. With what we discussed before with the segment routing, and mainly these days the segment routing with MPLS data plane, we are able to replace the IGP, LDP, and RSVP to create like a really unified transport based on the segment routing. We can still use the BGPLU on the top, or we can use even the segment routing for interdomain LSP. And then we have still LDP BGP, and you can see that this thing is running completely independently. It's actually the reason why I'm showing it here. That and at the same time you can take your BGP LDP based services and deploy it to the existing network, or even EVPN, which when you will bring it to the network. The next step is actually that we can even like simplify the services. So it means that the intention is not to have a LDP and BGP, because we removed already LDP from the transport. So why to keep the LDP on the services layer? Let's keep like one unique BGP control plane. And there was actually the question during the demo that Jakub was showing, for the SLA. This is another reason for unifying the services, because then your SLA will be completely same for your L2 VPN services, for your L3 VPN services, because you will have a BGP. BGP is the control plane. It's not about particular address family inside the BGP. It's really about the BGP. So when you look at the evolution of the Ethernet, there are actually two different tracks. A little bit, there was always like a difference between the data center network and the service provider. And what we are actually getting right now with the EVPN is we are basically merging these two together, because we had like Trail, Fabric path in the data center. Then we had all the time VPLS in service provider network. And when you look at like the DCI, the part where I need to stitch the services, typically the device is very complex. You need to understand different data planes and different data planes from the services point of view. So why we started with the EVPN, let's say in 2012, yeah. So there was like a need when first we will look at it purely from the service provider point of view. When we compare it with the VPLS. The VPLS has a certain technical limitations. For example, the first one, when I will have a CE1 connected to PE1, PE2, and when I will do the multi-homing, and theoretically I will do it like active-active, for broadcast, unknown unicast, and multicast traffic, when the CE1 will send something to PE1, PE1 will flood it in the VPLS core, will send it back to PE2, and PE2 will send it back to the access. Technology limitation. What I have to do? I have to keep a single active access, so it means I have to create some multi-chassis LACP, or when I have a hierarchical VPLS, I need to create the active backup pseudowire. Basically, this access is quite complex when you want to solve the problems here. The second problem, theoretically, when I will have this active access and I will send it on the opposite side, and I will send it again like the broadcast, unicast, and multicast traffic. Again, I will have a duplicity on the CE2 here in this case. And last one, very important, is when I will do any certain balancing inside a core. The PE3 in this case will see the source MAC address first from PE1, Second time, we'll see the same source MAC address from PE2. So what will happen in MAC address table? I will always do the rewriting. So I will have MAC address flip-flopping in this case. So all this stuff we are trying to solve, or we are solving with the EVPN. There is actually another reason these days, let's say roughly around 2016, we started to work much more on the simplification of the DCI, how to really connect the small data center or distributed data center to the service provider network. The reason, 5G. Everyone see that there will be needs to have a certain kind of like the data centers, SP data center, next generation data center, whatever you will call it. In the end of the day, you will need to create some certain fabric for your VMs inside the data center. Another very important part is the removing another protocols, because I mentioned that, for example, when you want to do today without the EVPN, the way how you want to multi-home the Ethernet, you are using the multi-chassis LACP. Typically, you are using ICCP. So with the EVPN, you can completely get rid of the ICCP. You can completely get rid of HSRP, VRRP, all these, let's say, legacy protocols which we have in the network all the time. There is a lot of things what we are bringing to the service provider network, mainly from the data center, because mainly in the data center, the requirement was with the optimal forwarding. It's not anymore hub and spoke. You need to do the routing directly on your leaf or on your top of your switch. And when you bring it to the service provider network, you will actually realize that the leaf in the data center is actually completely same like access router in the service provider network, and I will show you why. When you will be interested in real details, the main RFC 7432. We will divide it on the two multi-point, point-to-point. It's very important. Sometimes the people are skipping the EVPN VPWS. It's a very nice thing how to do the multi-homing. And again, not to do MAC address learning. It's not just a pure replacement of the traditional pseudowire. Then EVPN, and very important part is this EVPN IRB. This is something where I believe it makes sense to pay attention, because this is a way how you can integrate L2 and L3 together, and how you can get really optimal forwarding in your network. So then when we look at on the whole picture, like from that we have on the left side, we have a data center or SPDC, then we have some core, and we have let's say access. I'm always drawing the access like a ring, because ring is complicated. So when you are solving the problem in the ring, you will probably solve your problem anywhere else, right? So when you look at the existing protocols, very often, you can see even like the spanning tree VLANs in the data center. Then you will have VPLS with the MPLS transport in the core, and again you will have MPLS transport in your access when you don't have legacy like G8032 rep and so on. But when you will bring segment routing with MPLS, for example in this case, and then EVPN control plane, you actually realize that really the configuration and the protocols which you are running in your service provider data center and the protocols which you are running in your access are completely same. When you look at the provisioning and the configuration, what will be the difference between your leaf and the access router? At the end of the day, almost zero, right? So what we are getting is that we can really get the unified a transport as well as a service for both SPDC as well as access. Only difference what will be here is the physical topology, because in the data center again most probably you will have a leaf spine, you have enough fibers, the optics are cheap. In the access, it can be more complicated, right? So with the EVPN, you can see that we can basically go over all the existing type of the services and we can replace all of them. Very important statement here, and I will talk more about it. There is no intention to go and replace traditional L3 VPN service like VPN v4, VPN v6 by EVPN. There is no technical reason. I never heard about a technical reason why to do this, because again, the control plane is a BGP. If I'm running two address families, there is no difference between this. And actually, when you look at how many different features you can have today from VPN v4, VPN v6, and you will come and you will just replace it with EVPN L3, you will not get anything on the top. Here is a list of the things which are, I believe, that really like the advantage for the EVPN, and at least makes sense to look at it, and you will be able to think why. I like this second one, L3 VPN-like principles. Yeah, because again, everything is a BGP. You are even like when you look at like configuration, for example, on the IL6R, when you see how we are handling the route types, and I will talk about it later, you will see that it's really like L3 principles. ECMP, how you know everything from the L3 VPN. You can choose the different data planes. I mentioned the MPLS with the segment routing, but again, the service is independent. You can use your existing LDP. You can have a VXLAN. Later on, you will have a SRv6 with the EVPN and so on. And again, we are back to all the type of the services like ELAN, E-Line, E3, and so on. And most important, again, we are talking about open standard, obviously here. This slide here, I basically talk about this most important part. The EVPN there is mainly for L2 services, and also when you want to combine L2 and L3 together. When the service is purely L3, you are still using your existing VPN v4, VPN v6 service, which you have today. All the time, it's still one control plane. I was saying that the EVPN has two flavors for me. So one of it is what we discussed, like the best benefit is all active each access. So basically, I'm able to remove multi-chassis LACP, STP, targeted LDP, BGP auto-discovery, and so on. And at the same time, I can use EVPN as a standard multi-chassis control plane. Basically, I can remove then proprietary protocol like VPC, VSS, NV cluster. This is like all the Cisco protocols. Then again, we are back to removing HSRP, VRRP, and all these also standard protocols there.
Could you go back to the previous slide before that just for a second? It was the different data planes. Not that one, the one before that. There were the different data planes that you had. No, it's, keep going. It was back, I'm sorry. Yeah, no, you can go back ahead. There was one back from where you were, but it had the different data planes. It just showed that the EVPN had 3 different data planes.
Yes, but
yeah, that was it.
This one.
MPLS SR, that's what I was missing. Okay.
Yeah, MPLS SR. Basically, MPLS can be even LDP.
Gotcha. Okay.
Yeah, and also SRv6. You have like the separated arrow. Okay, perfect. So the most important part with the EVPN is that we are distributing the MAC addresses with the BGP. Yeah. So before, what we had like with the VPLS, we didn't have basically any signaling protocol for the MAC addresses. We just flooded and we had the data plane learning. Here on this side, what will happen is like the leaf will receive the MAC address, will do the data plane learning from the access interface, and will advertise this information through the BGP. And we will talk about details right now in the next slides. The reason why I was showing it on the leaf, again, all the concepts which we will talk about here, you can choose your side. Yeah? You can pick up if I will talk about spine leaf and connecting the compute, or I'm talking about the CE connected to the PE. The principle is completely the same. And again, when you look at like even the configurations, everything is equal. For the EVPN, there are important components here. The first one is that we are creating a certain instance like EVI. This is a completely same like you had before for example, in the bridge domain, you created the VFI for the VPLS. The next one, very important, is the Ethernet segment. Ethernet segment is something that will help me to identify if I'm doing any kind of the multi-homing. So here, for example, for CE1, I see that I have a single link, so Ethernet segment will be typically 0. I don't need to identify any Ethernet segment. But here for the CE2, where I'm doing the multi-homing to PE1 and PE2, I need to specify the Ethernet segment ID, because this ID will tell me on PE1, PE2 that basically I need to take care of the same broadcast domain. I will show you later how we'll solve this. Then, because again, we have a BGP, so we have a different route types. Today we have even more for the multicast, but the first 5 are the most important. And very important is the route type 2 for distributing the MAC address. But when you will be careful, you can see that with the route type 2, I can distribute MAC address, and optionally, I can also distribute the IP address, which is like a host route. This will then help me to also synchronize not just the MAC address table, but also the ARP information on the two routers. And when we will talk about L3, it's a very important one. The reason why the EVPN can act as a completely like the L3 VPN service is that we have a route type 5, which is distributing the prefix. So when you really want to have just the EVPN inside your network without the VPN v4, VPN v6, you can. It's not that you cannot, you can, but there are certain reasons why to stay with the VPN v4, VPN v6, because of all the feature set which you can get from the past. So how will we discuss? First, what I need to do is identify the multi-home Ethernet segment. So typically what I'm doing, I go and I will configure the Ethernet segment here on the both leaves. Basically, they have a same ID. And when these two routers will start to talk over the BGP, they will realize that they are sharing same Ethernet segment. And based on this information, they need to protect the loops, mainly for the broadcast, anonymicast, and multicast traffic. So how this will happen? So when the C here, or CE, will send the broadcast, anonymicast, and multicast traffic to the leaf 1. Leaf 1 will then flood it over the core, and the second leaf will receive the traffic back. And what will happen with VPLS, that what I said, that I will send it back to the access, and I will create the loop, right? So here what I'm doing is that before the leaves will start to send the traffic, they will negotiate something what we call the BAM label. There is additional label which says, hey, I'm L2. When you are sharing the same Ethernet segment, and there will be some broadcast, anonymicast, and multicast traffic coming from this Ethernet segment, and you will send it to me, please impose also the broadcast, the BAM label, because then I will know about it, and I will not send it back to the access. Now question is, when this guy knows that this guy will drop it, will not send it to the access, why he's sending it? The reason is that I can have also the single home device, which will be in the same bridge domain, and to this single home device, I need to send this traffic. Basically, I need to be transparent in L2, right? So again, this BAM label is per Ethernet segment. So now we know how to protect the loop coming from access, core, and back to the access, right? Then, if you remember, we discussed that with the VPLS, I have also the problem on the remote side, that I will send the broadcast and anonymicast traffic, and the remote side, both of them will send it back to the access. So basically, I will have a duplicity here. What will happen here, that the leaves also will agree who will be the DF and who will be non-DF. And just for this broadcast, anonymicast, and multicast traffic, only one of them, only DF, will forward the traffic to the access. Again, for the unicast traffic, I'm doing the active balancing here.
So I think you mentioned in a previous slide, but that's always been a struggle with VPLS delivery, especially in HA. If you're getting into a CE and delivery to a customer, is being able to have two-layer 2 paths. So EVPN solves that problem for service providers, I guess, as well as enterprise.
Yes, because now what I have with the EVPN, I'm able to send for the unicast traffic. I'm able to balance between the both leaves for the remote side. At the same time, when I'm saying the broadcast, which is obviously flooded, I'm able to decide, who from this leaf will forward it to the access.
Gotcha.
And when you look at it again, like from the BGP point of view, when we would look at like L3 VPN point of view, this is just a multipath. This is BGP multipath in the core, right?
So what does that look like? What does that look like south of delivery to the customer? Is that LACP? Is that two independent L2 links? What does that look like?
The best thing what you can do, and I will talk about the way how we connect the access. The simplest way is to have the bundle, basically LACP.
Gotcha. Okay.
Any type of the bundle, because for you it's a transparent. I will actually talk about the models. There is actually one model which is coming later this year, and it's actually very cool. I will talk about it later. So then, what we have also here, we talk about this. We talk about this balancing, and now the question is, how actually the remote node knows that can balance over the two leaves Because the MAC address learning basically compute when I will create a bundle here, transparent bundle, will just do the hash and will send it to one of the leaf, right? You will not do any flooding here. For you, it's from the C point of view, it's like a transparent link. So for example, here I go to L1, I will learn this MAC address on the L1, and I will advertise it everywhere. And now question is how the remote leaf knows that can balance over both of the leaves. Again, because even the remote leaf knows about the Ethernet segment. So what I have, I'm able to pair the MAC address is behind certain Ethernet segment, and I know that Ethernet segment is connected to leaf 1 and leaf 2. So then I'm able to do balancing. What we call it in EVPN, it's aliasing. You can imagine like aliasing is something similar like multipath in case of the L3 VPN service. And now, very nice part, which you are not able to do with the L3 VPN, is the mass withdrawal. It's a very fast convergence because when you will lose the link, normally what you would have to do with the BGP, for each particular MAC address or for each particular prefix, you will signal, okay, I lost this prefix, right? In this case, you will just send one route, say, hey, this Ethernet segment connected to me is that. So all the remote leaves, what will happen here, they will not go for each particular MAC address. They will just go say, for this Ethernet segment, leaf 1 is not there. So the convergence time is much, much, much better than it would be like when you would signal all the particular routes there. Another, mainly for the data center, this is not typically for the SP, is for the MAC mobility. So small thing in the route type 2, what we have a sequence number. So when the leaf 1 will advertise the MAC address of the VM1, sequence number will be initially 0. You will move the VM, new leaf will learn the MAC address and will increase the sequence number and will send it to the network. So everyone, just because they will see the higher sequence number, higher revision number, we will call it, they will immediately update the forwarding information. So mainly for the data center, it's very fast for the MAC move. And now here we are here for the different way how to connect the Ethernet to the network. And this is probably the most interesting part from the access point of view. The best way is to have the bundle, transparent bundle, LACP or port-mon, doesn't matter which protocol you will be using there. But transparent bundle, because for C point of view, you are getting like basically like one device. Then what you can do, you can have like a single active. This is in case when you want to do the certain QoS, for example. When you have a QoS on PE1, PE2, you will want to have it like active backup because you cannot do the distributed QoS, right? So in this case, you will have two completely transparent links to PE1, PE2. You will do for example, PE1 will be active. You can do it per VLAN active for the QoS and so on. And then the mode which is coming actually soon is the port active. Is the moment where you want to configure the transparent bundle over the both links, and at the same time, you want to be sure that only one link will be active. So what we are doing here, the PE1 and PE2 will agree who will, from the LACP point of view, will bring the one side of the bundle down. So you will see on the CE that, for example, here in this case, PE1 is basically sending the error on the LACP out of sync. So CE as well as PE will use just the link connected to the PE2. And now the question: when I will want to connect, let me first jump to this one. I can also connect the legacy. So when I will take any existing ring like GAT32 REP, STP, I can connect it to the EVPN. What will happen here, from the EVPN point of view, is like a single home, because what will happen, the control plane, which is running here in the ring, will somehow break the ring, right?
Oh wow, that's really cool.
Will take care about it. So from the EVPN point of view, it's just a single home network.
So I can take either end of an 8032 ring.
You just need to be sure that the device, the PE1, PE2, is able to integrate these things together.
Right, so as long as they are talking to, PE1 and PE2 are talking to each other, I can take opposite geographic rings, ends of an 8032 ring,
yes,
and tie it into that, which, that's pretty neat.
Yeah, because from EVPN, think about it, from EVPN point of view, let's say the ring will be broken here. We'll see that CE1 is connected to PE2, and CE2, CE3 is connected to, CE1 is connected to PE1, and CE2 and CE3 is connected to PE2. right? Simple.
Gotcha.
Then always what is always the question? Then is the convergence. And what we are trying to really address now and working on is to get even for this scenario much better convergence times.
So yeah, I was going to ask about that because G8032 normally you're at 50 milliseconds of convergence. Well, how does that? Where are you at with EVPN?
It's a different use cases. Depends on which failure will happen when the link failure.
Yeah.
Typically, link failure is really fast.
Right.
What is more complicated is always the node failure because of the BGP. You need to signal the BGP information to the remote end, so then can be like the convergence time can be very similar like to L3 VPN service basically. There is actually very nice part, what we are able to do. For example, on the SR9K is you need to somehow be able to migrate your existing services, right? So now the question is how you will take the VPLS and EVPN and how you will connect it together. You can do it in one bridge domain. Today, you can configure the EVPN, you can configure VPLS, you can have like Ethernet access, you can have a VPWS, and you can even bring the EVPN VXLAN to the same bridge domain. So basically, you can have like the gateway which will be between EVPN and VPLS. And when you think about it from the EVPN point of view, the VPLS will be like single active network. So basically, when you look at it, like what we are thinking, like from the DCI point of view, that the VPLS for me is just the access interface, and I need to take care that it will be like a single active. To the VPLS, I cannot just say send active traffic, right? So when I will act as a single active, the mode which we discuss here, single active, I can easily connect the VPLS to the EVPN, and it's very hard how to migrate the legacy to the new service. Very important, and the way how we can replace the HSRP, VRRP, and provide the optimal forwarding. Here, what will happen here? I will configure the Anycast IRB interface, Anycast BVI. Basically, all these interfaces are same IP address and same MAC address. What will happen with EVPN control plane? If you remember, for route type 2, I can distribute the MAC address as well as IP address, like a host route. So what I will do, I will synchronize the MAC address table for all the VMs which are coming to the leaves, but I will also synchronize my ARP. And this is very important when I have a BVI, because theoretically, I will send, and when I will have a transparent channel here, the leaf one will send the ARP to the compute, but I'm not sure that I will get it on the same link back, right? Because this is a transparent channel. I cannot control it. So CE will do the hash and will send it always to the second leaf, because for CE, we are like one device, right? So I need to have EVPN control plane to synchronize MAC address table and ARP table for the unicast traffic.
So you can take any subnet and then you distribute that gateway for that subnet as an Anycast next hop. Because I see in the IPv4 world and the shortage that we're in, one of the use cases we have, especially for small providers that haven't grabbed like an enormous amount of space, like a tier 1, is, and rather than breaking that subnet up out into the aggregation layer, you consolidate that subnet near your border routers and then have an available gateway through some kind of an L2 overlay like VPLS, which normally we have to involve VRRP or something else like that, but that kind of takes it to a whole other level by distributing that gateway regionally.
Yes, this is same IP address everywhere. And this can be like region A, this can be like a region B.
Yeah.
And you are right. When you want to save something in the subnet, you need to have like one big subnet, right?
Right.
Bigger subnet means that I am able to save more, right?
Sure.
It's very simple. So, and in this case, the nice part is that you don't have to configure anything on the top. You just configure the IP address and the MAC address. You must be sure that the MAC address will be also the same. Because when I will take this VM and I will move on this side, I need to be sure that the MAC address on the same subnet will be same, right?
Cool.
So this is actually a very, very nice part, and this is the reason why I'm saying that sometimes it's really the EVPN can be running just between two nodes as a standard control plane for the multi-chassis, because I can imagine that I will run it here and then I will have L3 VPN service even over the core. Another thing is that when I have this distributed Anycast gateway, I can do easily routing directly on the leaf. And this is important. Then I have a super optimal forwarding because when I have a red and orange subnet here, I'm doing the routing decision directly on the leaf, directly on my CE, or sorry, directly on my access router or P router, right? I don't have to go to my DCI, border leaf, or router and go back. So I'm optimizing the southwest, south-north, and east-west traffic as well. There is two approaches. One is the distributed anycast gateway, which we discuss right now, and then it's a centralized. Basically, I have one centralized gateway on the DCI. Typically on our devices, we are supporting the distributed anycast gateway because it makes sense for the distributed forwarding. There is also one important thing. When we discuss this distributed anycast gateway, we call it symmetric or asymmetric IRB. We have always implementation of the symmetric IRB. Symmetric IRB is kind of like a routing. I will get a packet to certain subnet. This is like a black subnet probably here on the table, normally no. Then I want to route to the red subnet, so I will do directly a routing decision here on this leaf. So I'm saying that I'm doing the bridging and routing on the ingress leaf. With the asymmetric IRB, it's coming typically with the limitation where on the egress leaf, I'm able to do just the bridging. So what will happen here is that I will do the routing, I will bridge to the particular VLAN, particular EVI, and then send it to the egress router, and egress router is just doing the bridging. The disadvantage of the asymmetric IRB is that basically I need to keep the MAC addresses everywhere. Here, on this leaf, when I don't have the red subnet, I don't need to have a MAC addresses for the red subnet, right? But here, even when just want to route, I need to keep the white subnet because I need to know the destination MAC address. Here I wanted to just show the interconnect between EVPN and VPN-V4 because this is something when the people are getting like the feeling that they don't need to do the border leaf or the DCI. And with the MPLS, I'm trying to demystify this, that it's basically always needed to have this DCI and border leaf. Because typically in your data center, you will have a host route, right? And when you want to interconnect it with your L3 VPN service, you don't want to distribute this host route or /32 to the remote PE or remote access, right? So typically what will happen here, you will just summarize all the host routes and you will send just the holder prefix. And now the way how we are doing it. We have this route type 2, which is doing the host route inside my EVPN cloud here. This route type 2, I said I don't want to distribute to the VPN-V4 or VPN-V6. I have also this route type 5, which are sending me holder prefix, which I have connected to the leaf. And this route type 5, I'm able to convert to the VPN-V4 update and vice versa. So what is happening here is that basically from the BGP point of view, we have inside the VRF, we have two different routes target for import and export. And we are just leaking between address family EVPN and address family VPN-V4, VPN-V6. Very easy. And this is typically like one-time configuration. So then the configuration of your DCI or border leaf is very simple. And actually, this node is not participating in any L2. You don't have any bridge domain here. You don't have even L3 interface in your VRF. That's a very important part. Super simple then for integration. Again, because we are using one control plane, which is BGP, just leaking between different address families. So then, when we discuss this SLA, how it looks like when I want to have end-to-end SLA, my leaves are sending, inside the BGP community, are sending the SLA type for the service, right? So then, I will take the same extended community, and I will advertise it inside my VPN-V4, VPN-V6 update. And again, because I have one unique transport, I can decide which policy will be used for forwarding between A1 to the DCI and then from the DCI to the leaf. Typically from the DCI to the leaf, you don't have any different SLA types because your transport is always equal because you have a spine and leaf. I promise that I will also mention the EVPN VPWS. Again, it's not just the replacement of the VPWS because you can do still multi-homing without the MAC address learning. Again, It's very important in case when you need to scale this device are low scale, you cannot do or you don't want to do the MAC address learning there. Very, very powerful tool. Another option is what we are bringing this year is the EVPN E3. So basically, you are specifying who is a leaf, who is a root, and a leaf cannot talk to leaf. They have to always talk to the root. Integration with the multicast. Same what we are doing for synchronizing the MAC address and ARP. We are also able to do for IGMP sync. Basically, I will get the IGMP, I will do the snooping, and I will sync this IGMP with my remote leaf. Very, very similar process. Another nice part is EVPN flexible cross connect, and it's a way when I have multiple CEs connected to my access nodes, and I am able to max everything and create one EVPN VPWS pseudo wire to my PE. And basically here, before I'm sending it back to the A, I'm doing the max and demax on the VLAN level. So from the control plane point of view, then it's very simple. Typically, you have just one EVPN VPWS from your A1 and A2. This one, which is coming later this calendar year, is the integration with the pseudo-wire headend in case when you want to do the centralized QoS. And this is something where we are bringing some enhancements because today you don't have any way how to do the redundancy on the pseudo-wire headend side. We will again use here the EVPN, and based on the EVPN, we will drive the status of the pseudo-wire headend interface. So because for QoS, again, you want to have just one interface active at one time because you want to be sure that you are doing your QoS stuff. Otherwise, you can use your IRB here if you want active. But EVPN will take care that, for example, PE2 will bring down the pseudo-wire headend interface, so everyone will use the PE1, and when PE1 goes down, you will automatically bring up the pseudo-wire headend interface on the PE2. So this is a last slide to summarize what basically all the flavors with the EVPN, what you can do. So when you look at it, like we are able to cover the multicast, we are able to integrate it with the multicast and VPN address family. We are able to do IGMP sync. We have a flexible cross connect when you want to simplify your signaling. We have EVPN headend in case when you want to do the hierarchical services with the QoS. E3 when you want to have the rules that, for example, client is not talking to client. Everyone has to go first to the root. For example, BNG use case can be this one. We have a point-to-point services with the EVPN VPWS, traditional L2 bridging, multi-point L2 VPN service, integration with L3 with Anycast IRB, which has two flavors. First is like integration with L3 with the default gateway. Second one is the standard multi-chassis for standard control plane for the multi-chassis.
I've got a question for you.
Sure.
And we talked at dinner last night about the difference between data center topology physically is when you need fiber in a data center, you just run it wherever you want. And I always say in a service provider architecture, it follows the geography. Yeah. So what are the challenges in implementing leaf spine when a mountain is suddenly in the way?
Exactly. It's like I'm always saying that when you will have enough fibers in your access, you will probably have a spine leaf architecture last 20 years, right? Because spine leaf architecture is not something what we figure out like yesterday. It's just the service providers, they cannot do spine leaf in the access because they don't have a fibers. Or also there is another problem. You can have a fiber, you can create a DWDM.
Sure.
But in data center, the distance between my spine and leaf, it will be always like 1 meter, 5 meters, and there is no difference if you will use like 1 meter cable or 5 meters cables or 5 feet cables, whatever. Sure. It doesn't matter. But when I will have DWDM, I can have like one link can be like 10 kilometers, but second link can be 200 kilometers, right? So then you will have a problem because do you want to really do the ECMP?
Well, that's what I was curious about is when I start taking alternative paths and you start covering some serious distance and latency becomes a factor. What does a leaf spine architecture look like when it's over those paths?
When you look at this one, what we are proposing with the transport, we are basically like physical topology completely agnostic. We don't care about it because, for example, when you listen to the presentation of the Jose, he talked about the flex algo. One of the flex algo is using the latency information from the network. So basically, I'm able to figure out what is my latency information.
So unlike data center leaf spine, where it needs to be deterministic, your transport is accounting for the variances in the paths, and you don't care.
I don't care. Exactly.
Yeah, I got you.
I don't care. Just one thing. For example, in the data center, most probably, I will not have any flex algo because everything is equal. I will not, I cannot imagine that in data center, I will be saying, okay, this link has a SLA1 and this link has a SLA2. Most probably, everything will be equal. This is more important for the service provider access because there you want to be sure that you are using the right link.